We have a liftoff. Very recently, NASA received a set of confusing transmissions from the Voyager 1 spacecraft. Having traveled in space for over 4 decades, the Voyager project had journeyed into regions of the solar system never explored before. This garbled information and glitch output set off a series of tense investigations into the source of this transmission. As a result, experts have found some anomalies in the space probe's performance as it transmits enigmatic signals. What may have caused the transmission of this terrifying data to Earth? Has this space probe been tampered with by otherworldly species? To answer these questions, we must first understand how the Voyager is supposed to function. Join us as we examine why Voyager is sending back terrifying data to Earth. Voyager stands as one of the most successful space missions ever spearheaded by NASA. First conceived as a space grand tour of our solar system, Voyager would go on to become the longest-running space program and NASA's biggest planetary expedition. The two Voyagers have explored more planets, discovered more moons, and returned more photographic images from space than any other space flight. The Voyager project has its origins deep in the discovery of an astronomical event called planetary alignment. This is when several planets gather closely on one side of the Sun simultaneously. This event can be observed on Earth using powerful binoculars and telescopes. Planetary alignment happens once every 175 years, which makes it an extremely rare phenomenon. In 1964, an engineer from NASA's Jet Propulsion Laboratory noted that there would be an alignment of Jupiter, Saturn, Uranus, and Neptune in the late 1970s and early 1980s. After popularizing this event, the Jet Propulsion Laboratory promoted the Grand Tour project. This would allow for 2 space missions assisted by the gravitation from each planet to save time and fuel. The Grand Tour initially involved 4 spacecraft and cost around $1 billion. This was, however, scaled back due to cost and technical constraints to include 2 spacecraft. Although the then President of the United States, Richard Nixon, gave the White House support, congressional pressure led to the downscaling of the project. Voyager 2 left Earth first on August 20, 1977, after being lifted off on a rocket at Cape Canaveral Space Force Station in Florida. Voyager 1 launched 2 weeks later in September and marked the beginning of an epic journey into the outer solar system. Each Voyager is equipped with a suite of 11 key instruments which it uses to study planets during encounters. They possess an imaging science system with both narrow-angle and wide-angle cameras to take photographs. They also have a radio system to determine a planet's physical properties, an infrared interferometer spectrometer to investigate energy balance and atmospheric composition. The Voyagers can also measure the atmospheric properties, magnetic field, surface composition, and magnetosphere of a planet. These instruments have formed the basis of most of what we know about these planets. As of 2013, the probe was moving with a relative velocity of about 38,000 miles per hour and traveling nearly 325 million miles per year. The Voyagers were built with the potential for interstellar travel in mind. The space probes include a large 12-foot parabolic high-gain antenna which receives data through the Deep Space Network from Earth. The probes are also powered by 3 multi-headed Watt radioisotope generators supplying power to the probe into the foreseeable future. The probes were also designed with a robust propulsion module with 8 hydrazine monopropellant rocket modules. This allows the probes to execute trajectory correction maneuvers and stabilization of the spacecraft on its axis. In January 1979, Voyager 1 began photographing Jupiter. Its closest approach was in March 1979 at a distance of about 217,000 miles from the planet's center. Most images of the planet, its moons, rings, and magnetic fields were taken within 48 hours of the closest approach. Voyager 1 discovered ongoing volcanic activities on Jupiter's third-largest moon Io, which surprised scientists. This was the first time active volcanoes were observed on another body in the solar system, which was exciting for space scientists. Io's volcanic activities were discovered to be the primary source of the sulfur, oxygen, and sodium in the planet's magnetosphere. Voyager 1 also gave details of Jupiter's other moons including Europa, Ganymede, Callisto, and Amalthea. Voyager 2 approached Jupiter shortly after, sending 177,000 images of the planet and its moons back to Earth. It confirmed Voyager 1's discovery of a thin ring encircling the planet. It discovered several new satellites and 2 new moons, namely Thebe and Métis. Using the gravitational assistance of Jupiter to propel their trajectories, both Voyagers went on to visit Saturn. Voyager 1 encountered Saturn about a year later, making its closest approach in November 1980. Voyager 1 was 77,000 miles from Saturn's cloud tops, studying the planet's atmosphere and giant moon Titan. Voyager 1 found that about 7% of the volume of Saturn's upper atmosphere is helium and the rest is hydrogen. The space probe found high-speed winds on Saturn, with winds measuring about 1,100 miles per hour near the planet's equator. We also discovered ultraviolet emissions of hydrogen similar to the aurora lights on Earth. After flying past Jupiter, next was the flyby of Saturn's largest moon Titan. Voyager 1 also discovered 3 new moons, namely Atlas, Prometheus, and Pandora, thereby increasing the number of Saturn's known moons from 12 to 15. Titan was found to have a thick atmosphere, making this the first true evidence that another celestial body other than Earth has a thick atmosphere. Voyager 1 captured amazing close-up images of Saturn's ring, confirming that the ring is made up of countless small particles and has gaps and ringlets. During this flyby, we calculated Saturn's rotation rate to be 10 hours and 39 minutes. This was made possible by careful tracking of the interior clouds. NASA was also able to confirm the diameter of Saturn to be 120,000 miles at the equator, just as was estimated from Earth. Voyager's visit to Saturn significantly impacted our understanding of the planet. The Voyager 1 sent back about 16,000 images among other significant scientific data from its Saturn flyby. On January 24, 1986, Voyager 2 began its closest approach to Uranus, coming within 50,600 miles of the planet's cloud tops. It discovered 11 previously unknown moons of Uranus, including Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, Puck, and Perdita. The probe further studied the planet's atmosphere and Uranus ring system. From this probe, we know that the length of day in Uranus is 17 hours and 14 minutes. Unlike other planets, Uranus also showed a magnetic field that was misaligned with its rotational axis. It possessed a helix-shaped magnetic tail and a cloud hidden by a haze layer. The concentric clouds of Uranus also showed large amounts of ultraviolet light in a phenomenon called dayglow. The Voyager 2 space probe had a flyby of Uranian moon Miranda, showing some huge canyons which are thought to be formed from geological faults. Scientists believe that Miranda might have shattered into pieces in the past due to a violent impact. It is said that the current state of the moon is the reaggregation of the shattered particles of the moon. The probe discovered 2 previously unknown Uranian rings. After measurements, we found that the rings distinctly differ from those of Jupiter and Saturn. The Uranian ring system is relatively young and was not formed simultaneously with the planet. It is believed that this thin ring was formed by the remnants of a moon that was broken up by a high-velocity impact. After a mid-course correction in 1987, Voyager made its closest approach to Neptune in August 1989. The probe went on a trajectory through the Neptune-Triton system. Voyager 2 performed a close flyby of one of Neptune's moons, passing within 25,000 miles. Voyager 2 discovered 2 previously unknown moons and confirmed 6 new ones: Despina, Galatea, Larissa, Proteus, Naiad, and Thalassa. The probe also observed a phenomenon called the Great Dark Spot in Neptune's neighborhood. This phenomenon has since disappeared, as the Hubble Space Telescope can no longer observe it. Experts believe that the Great Dark Spot was a region of clear gas forming into a high-altitude methane cloud deck. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, making the flyby of Neptune in 1989 a pivotal moment in space exploration. This was the point where every known planet in the solar system had been visited at least once by a space probe. One of the greatest achievements of the Voyager missions was the Solar System Family Portrait. This is the final series of 60 images captured by Voyager 1, showing 6 planets from our solar system. This was the first and only time a spacecraft attempted to photograph our solar system. Only the Voyager 1 and 2 and the New Horizons spacecraft have been able to make such an observation. In 1990, as Voyager 1 was making its way beyond our solar system, the mission managers commanded it to look back towards home for the final time. The mosaic of images showed how tiny our planet looks from a great distance away. Voyager 1 captured images of Neptune, Uranus, Saturn, Jupiter, and Venus. These images were taken beyond Neptune, at about 3.7 billion miles from the Sun. In the image, Earth was a tiny dot within a scattered ray of sunlight, while Mars was obscured. Mercury's position around the Sun made it impossible to capture in the image, and the former 9th planet Pluto was too far away and tiny to be detected in this image. The image gave us an awe-inspiring and unprecedented view of our world and its neighbors. The family portrait taken by the Voyager spacecraft helps us see our world in a new and bigger way. It shows the scale of the solar system and highlights the scale in relation to Earth. This mosaic required a combination of methods to produce. The image does not have a unified appearance, as individual frames had to be acquired using various filters at varying exposures. The Sun was imaged using the darkest filter and shortest exposure possible, while other frames were acquired in grayscale using the probe's wide-angle camera. The portrait was taken by Voyager 1 as it was appropriately positioned above the plane of the solar system, and its trajectory gave a clear shot of Jupiter. After the planetary mission, the Voyager transitioned into interstellar mission mode. This mission would enable NASA to find out what the solar system is like beyond the heliosphere. In March 2013, Voyager 1 was the first spacecraft to enter interstellar space after confirming changes in the plasma environment. Traveling at 330 million miles per year, Voyager 2 follows slowly behind at 310 million miles per year. In 2018, Voyager 2 followed suit into interstellar space, marking another milestone in our space odyssey. The Voyagers are the only spacecraft to collect data in interstellar space. The information they provide has helped drive a deeper understanding of the heliosphere, which is the diffuse barrier that the Sun creates around the planets in our solar system. Voyager 1 detected the increase in cosmic rays from outside our solar system, which was the first hint that it had crossed into interstellar space. The probe also observed the vibration of plasma particles, which was the first time we heard the drone of interstellar space. It also measured the changes in magnetic field direction and plasma density in the boundary region. The entry of Voyager 1 into interstellar space confirmed the existence of the heliopause. The size, shape, and structure of this former theoretical model have now been mapped, all thanks to the 2 Voyagers. This information will protect future spacecraft exiting the solar system. Hidden on both Voyager space probes is a gold-plated audiovisual disc containing photographs of Earth, its life forms, scientific information, spoken greetings, and a medley of sounds from Earth. If either spacecraft is found by intelligent life forms from other planetary systems, this golden record would be a pointer to its source. The medleys include sounds of whales, a baby crying, waves breaking on the shore, and a collection of music. The spoken greetings were made by the Secretary-General of the United Nations, the President of the United States, and children from different parts of the world. Songs of Wolfgang Mozart, Chuck Berry, and other Eastern, Western, and ethnic performers were included on the Voyager's golden record. After over 4 decades of functioning smoothly, Voyager 1 suddenly began transmitting strange signals to Earth. This puzzled scientists as the space probe has been in great working condition throughout its historic journey. The scientists found that the reading from Voyager 1's articulation and control system does not match what is happening on board. The articulation and control system helps with the antenna orientation and spacecraft position. The positioning and orientation of space probes are critical factors in space travel. The appropriate position of a probe's antenna helps with the proper transmission and receiving of commands from command stations. Any small deviation may degrade and disrupt the communication link. Orientation is also important for probes that rely on solar energy, as it maximizes solar panels' exposure towards the sun. Probes also have delicate instruments that require stability and balance to function optimally. The orientation and positioning system helps to avoid drifting or uncontrolled spinning. Other key instruments like cameras need to know the probe's orientation to capture the proper image and ensure accurate measurements. Positioning enables the engines to fire in the required direction for orbit entry in the event of orbital insertions and maneuvers. This was why the strange transmission from Voyager 1 was a major concern for the engineers on the Voyager project. The engineers have had to rule out the possibility that intelligent alien species control the Voyager space probe. It is indeed possible that to retrieve and access the details on the Golden Record, an alien species has tampered with the space probe. As intriguing as this possibility is, NASA has stated for Voyager 1 to function properly, the alien species may be unable to operate the altitude control mechanisms without a proper understanding of the spacecraft's design. There has been no conclusive evidence of tampering with the Voyager 1 space probe, and this maintains the possibility that NASA is keeping the details of this until it can get accurate data. As the engineers scrambled to diagnose the issue on this space probe billions of miles away, new anomalies continued to arise, further deepening the puzzle. Shortly after, Voyager 1 returned to operating normally, receiving and executing commands from Earth. However, the mission team continued to search for the source of the system data issues. All signs suggest that the attitude and articulation control subsystem is still working, but telemetry data returns as invalid. The issue has not triggered any fault protection system. This fault protection system flags important errors and can put the spacecraft into safe mode, thereby shutting down all non-essential operations. Due to the distance from Earth, light takes 20 hours and 33 minutes to travel to the space probe. This means it would take 2 days to send a message to Voyager 1 and get a response. Suzanne Dodd, the project manager for the Voyager program in California, stated that such mysteries are expected for the later stages of a space mission like this. She stated that the 45-year-old space probe is far beyond the expected mission plan, which can lead to some anomalies. She further noted that the spacecraft is now in interstellar space, a high-radiation environment that no other spacecraft has flown before. Dodd is, however, confident that if there were a way for the engineering team to find the source and resolve the anomaly, they would. This incident would not be the first time the Voyagers have had to rely on backup hardware. In 2017, Voyager 1's primary thrusters showed signs of degradation, so engineers switched to another set of thrusters originally used for planetary encounters. The thrusters worked seamlessly even though they were in use for 37 years. Although the Voyager space probes were designed to last 5 years, they continue to be operational after 45 years of their launch. They transmit data back to Earth and provide significant insights into how our solar system works. Due to the diminishing electrical power available, the Voyager team has had to prioritize the instruments to keep on. As a result of power management processes, the heaters and other spacecraft systems have been turned off. Only the fields and particle instruments are prioritized and kept in operation, as they provide key insights into the heliosphere and interstellar space. The engineers expect the space probes to continue operating at least one science instrument until around 2025. The Voyager 1 probe remains the farthest and far-reaching probe sent from Earth. Provided it does not collide with anything and remains unretrieved, it is expected to reach the theorized Oort cloud in about 300 years and take about 30,000 years to pass through it. The Voyagers seem destined to continue wandering the Milky Way. Although launched at a higher speed than both Voyager spacecraft, the New Horizons space probe will never surpass the Voyagers. The Voyagers benefited from multiple planetary flybys, which increased their heliocentric velocities, while the New Horizons received a single boost. Other space probes include the Pioneers 10 and 11 and the New Horizons spacecraft. Launched in 1972 and 1973 respectively, Pioneer 10 and 11 were designed to carry out close studies of Jupiter and Saturn. Pioneer 11 is currently heading towards the constellation Aquila after leaving the Solar System. The New Horizons was launched in 2006 and was the first space probe to fly past Pluto. It gave us our first close-up view of Pluto's surface, its geology, and composition. New Horizons also examined Pluto's moons and flew by the Kuiper Belt object Arrokoth in 2019. These bold missions expanded our understanding beyond the scope of the Voyagers. Over 40 years into their flight, the Voyagers remain at the front line of space exploration. Their plutonium power source will allow them to continue until around 2025, when the power runs out. As of today, Voyager 1's twin, Voyager 2, continues to operate normally. No matter what the future holds for the Voyagers, we can be proud because they have completed their mission far exceeding their expected lifespan. They've helped us properly understand our solar system and carry pieces of our species into the cosmos. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.